Hello, and welcome to the Sleepy Science Facts. Tonight, we will gently drift into the ever-changing world of weather, the endless dance of sky and storm that surrounds our planet every single day. At first glance, the sky above us can seem simple and calm. Yet, in truth, it is filled with motion, complexity, and quiet wonder. It is like a vast ocean made of air, constantly moving, swirling with winds, painted with clouds, and stirred by invisible rivers of heat. Within this delicate atmospheric system, sunlight scatters into brilliant colors. Lightning splits the sky with sudden fire. Storms are born that can travel across entire oceans. Weather is more than the mood of the planet. It is its breath, its heartbeat, its rhythm. If you enjoy these gentle journeys through science, feel free to like and subscribe, or share one of your favorite facts in the comments below. It helps other sleepy explorers find their way here too, one calm mind at a time. But for now, there is nothing you need to do except relax. Settle in comfortably, take a slow breath, and allow your thoughts to wander into the fascinating world of weather. Let's begin. A single storm cloud can weigh more than 1,000,000 elephants. When you look up at a drifting cloud, it appears soft and almost weightless, like a piece of cotton stretched across the sky. But the reality behind that peaceful image is astonishing. A typical cumulus cloud, the kind you might see floating on a warm summer afternoon, can contain hundreds of thousands of tons of water. Each droplet inside the cloud is incredibly small, far too tiny to see individually. But when millions upon millions of these droplets gather together, their combined mass becomes enormous. In fact, a single cloud can weigh as much as more than 1,000,000 elephants standing side by side. And yet, despite this tremendous weight, the cloud remains suspended in the air. This happens because the water inside the cloud is spread into countless microscopic droplets. Rising currents of warm air push upward, keeping those droplets gently floating. Something so massive and heavy, appearing so delicate and graceful, is one of the great paradoxes of weather. The next time you tilt your head to watch a cloud lazily drifting overhead, remember that it may be carrying the weight of entire lakes within its soft and silent form. Lightning is hotter than the surface of the sun. In the blink of an eye, a jagged flash of lightning tears across the sky. To our eyes, it looks like brilliant white fire, but the true temperature inside a lightning bolt is even more astonishing. A lightning strike can reach temperatures of more than 30,000 degrees Celsius. That makes it several times hotter than the surface of the sun. The energy involved is immense. It is powerful enough to superheat the surrounding air instantly, transforming it into plasma and filling the sky with blinding light. This rapid heating causes the air to expand violently, and that explosive expansion is what we hear as thunder rolling across the landscape. Each lightning flash is like nature conducting its own experiment, compressing incredible heat and energy into just a fraction of a second. Some lightning bolts stretch for miles, connecting the clouds above with the ground below in shimmering chains of electricity. Yet despite its violent power, lightning also plays an important role in sustaining life. It helps convert nitrogen in the atmosphere into forms that plants can absorb in the soil. In this way, lightning quietly nourishes the ecosystems that support us. The sound of thunder is air exploding from sudden heat. Thunder often rolls across the sky in deep echoes, sometimes like distant drums, sometimes sharp and startling. What we are really hearing is the voice of lightning itself. When lightning flashes, the air around it heats so rapidly that the molecules cannot expand gradually. Instead, they burst outward in a sudden shock wave. That shock wave travels through the atmosphere as sound, and that sound is thunder. Depending on how far away the lightning strike occurs, thunder can crack loudly, rumble deeply, or echo between hills, mountains, and buildings. Because light travels much faster than sound, we always see lightning before we hear the thunder that follows. That is why counting the seconds between the flash and the rumble can help estimate how far away the storm is. In this way, thunder becomes both a warning and a wonder. It is a reminder of the immense forces at work in the sky above us, wrapped inside the rolling rhythm of a storm. Raindrops are not shaped like teardrops at all. In children's drawings, raindrops are usually shown as perfect teardrop shapes, pointed at the top and rounded at the bottom. But in reality, raindrops look nothing like that. The smallest raindrops are nearly perfect spheres. Surface tension holds them together in smooth, rounded shapes. As raindrops grow larger, however, air resistance begins to push against them as they fall. This flattens their bottoms slightly, giving them a shape more similar to a hamburger bun than a teardrop. If a raindrop grows too large, it becomes unstable and breaks apart into several smaller droplets before reaching the ground. Imagining the real shape of falling rain makes the process even more beautiful. Each drop tumbles from the sky in its own tiny geometric form. The teardrop illusion comes from the way water stretches when it slides down surfaces like windows or cheeks, pulled downward by gravity. But the raindrops falling through the open sky carry their own hidden shapes, small rounded jewels drifting gently toward the earth. The smell of rain comes from ancient oils and microscopic life. There is a special word for the earthy, comforting scent that fills the air after rainfall. It is called petrichor. This remarkable smell is created by several natural processes working together. During long dry periods, plants release oils into the soil. These oils slowly accumulate while the ground waits for rain. When raindrops finally strike the earth, they create tiny air bubbles in the soil. As those bubbles burst, they release microscopic droplets into the air, carrying the plant oils with them. At the same time, soil-dwelling microbes produce a compound called geosmin, which contributes a deep, earthy aroma. And during thunderstorms, lightning can break apart oxygen and nitrogen molecules in the air, forming ozone. This adds a crisp, sharp note to the scent that we often associate with fresh rain. The result is the unmistakable fragrance of a rainstorm, a mixture of ancient soils, living microbes, and atmospheric chemistry. When you breathe in that smell, you are inhaling a story as old as the planet itself. Snowflakes can fall at surprisingly different speeds. We often imagine snow drifting softly through the air, each flake floating slowly downward in silence. And sometimes that image is true. Some snowflakes descend gently, twirling like tiny feathers through the sky, but others fall much faster. The speed of a snowflake depends largely on its size and structure. Small, delicate ice crystals may fall at only a tiny fraction of a meter per second, hovering in the air as if reluctant to reach the ground. Larger flakes, formed from clusters of many crystals, can tumble downward at speeds of several meters per second. Wind currents add even more complexity. They may push flakes sideways, lift them upward again, or send them spiraling unpredictably. In some cases, snowflakes travel miles through the atmosphere before finally landing.
So when you watch snow falling, you are witnessing a quiet ballet shaped by gravity, air resistance, and the intricate architecture of ice. Every flake follows its own unique path through the sky before settling into the soft silence of winter. Some snowflakes grow wider than a coin. Most snowflakes are tiny, delicate ice crystals, often no larger than a fingernail. But under the right atmospheric conditions, they can grow to remarkable sizes. When the air is moist, the wind is gentle, and temperatures remain within a narrow range, snow crystals can stick together as they fall. Instead of remaining separate, they merge into clusters. These clusters can grow larger and larger as they tumble through clouds, sometimes forming flakes wider than a coin, or even approaching the size of a small dinner plate. The largest snowflakes ever recorded were reported in Montana in the late 1800s. Witnesses described flakes that measured more than 15 inches across. Imagine such enormous crystals drifting slowly from the sky, like frozen feathers floating through the air. While most of us will only ever see snowflakes the size of coins or smaller, the knowledge that the sky is capable of producing such giants adds a quiet sense of magic to winter storms. Every snowflake, whether tiny or large, contains an intricate structure of ice crystals that formed silently high above the earth. Blizzards can make it impossible to see your own hand. A blizzard is more than just heavy snowfall. It is a powerful combination of snow and strong winds that transforms the landscape into a blinding wall of white. Inside a blizzard, visibility can shrink to only a few feet. People caught in such conditions often describe the disorienting experience of being unable to see even their own hands held in front of them. Wind gusts whip snow off the ground and fling it back into the air, creating a swirling white storm known as a whiteout. In this environment, all sense of direction disappears. The horizon fades, landmarks vanish, and the world becomes an endless blur of moving snow. Temperatures often plunge, and the wind chill can freeze exposed skin in minutes. For those who live on open plains or high mountain slopes, blizzards are among the most dangerous forms of weather. They can easily confuse even experienced travelers. Yet within the violence of a blizzard, there is also a strange and haunting beauty. The world becomes a blank canvas of white, where silence and chaos exist at the same time. Hailstones grow in layers like onions. Inside powerful thunderstorms, rising columns of air called updrafts can lift raindrops high into the colder regions of the cloud. There, the droplets freeze into tiny pellets of ice. But their journey is far from over. These frozen pellets may fall downward again, collecting more water as they descend. Strong updrafts can then lift them back into the cold upper clouds once more. Each time this happens, another layer of ice forms around the growing hailstone. By the time the hailstone finally falls to the ground, it may contain many layers of frozen water stacked one over another. When sliced open, hailstones often reveal beautiful rings, much like the layers of an onion or the growth rings inside a tree. Each layer tells the story of another journey through the storm.
Small hailstones may bounce harmlessly off rooftops and fields, but larger ones can shatter windows, flatten crops, and dent metal. Some of the largest hailstones weigh more than a pound. Despite their destructive potential, they remain natural sculptures formed within the turbulent breath of thunderclouds. The largest hailstone ever recorded was bigger than a volleyball. In July of 2010, residents of Vivian, South Dakota, witnessed one of the most astonishing hailstones ever measured. A massive ball of ice fell from the sky. It measured nearly 8 inches across, about the size of a volleyball, and weighed almost 2 pounds. Imagine such a sphere of solid ice plunging toward the ground at high speed. Fortunately, it landed harmlessly in a field, rather than striking a person or building. But it remains the largest hailstone ever officially recorded in the United States. Across the world, other storms have produced similarly massive hailstones. These giants form only when extremely powerful updrafts repeatedly carry the growing ice stones up and down inside towering storm clouds. While most hailstones are no larger than peas, extreme examples like the one in Vivian remind us of the dramatic forces that shape weather. Under rare conditions, the sky can forge icy projectiles of truly astonishing size. Tornado winds can drive straw through solid wood. Tornadoes are among the most extraordinary forces found in nature. These violently rotating columns of air sweep across the land with incredible power. Within a tornado, winds accelerate to such speeds that ordinary objects can become deadly projectiles. One of the strangest and most fascinating observations from tornado damage surveys involves something surprisingly fragile: straw. Lightweight straw caught inside the winds of a tornado can be driven straight through solid wood. The intense wind speeds accelerate debris so rapidly that even the lightest objects gain enormous force. After tornadoes pass, investigators have sometimes discovered pieces of straw embedded deep inside wooden fence posts, telephone poles, and even the walls of houses. It is a startling demonstration of the raw power of spinning air. A tornado does not need heavy objects to cause destruction. It can turn grass into arrows. The fastest tornado winds rival jet aircraft. When we imagine powerful winds, we might picture hurricanes or massive storms over the ocean. But the most intense tornadoes exceed even those forces. The strongest tornadoes are classified as EF5 on the enhanced Fujita scale. These storms can produce wind speeds exceeding 300 miles per hour. That is comparable to the cruising speed of a passenger jet. In such winds, cars can be lifted and thrown through the air like toys. Steel beams may twist or bend. Entire buildings can be torn from their foundations and scattered across the landscape. Storm chasers who have survived close encounters often describe the sound of these winds as similar to a freight train rushing toward them, a deep, overwhelming roar. Thankfully, tornadoes of this intensity are rare, but their existence reminds us that the atmosphere can concentrate enormous energy into small areas. They are among the most powerful bursts of weather on Earth. Hurricanes release more energy than all power plants combined. A hurricane is a storm so vast that it almost defies imagination. Spanning hundreds of miles across the ocean, hurricanes gather energy from warm tropical waters. As warm air rises and moisture condenses into clouds and rain, enormous amounts of heat energy are released. The amount of energy produced by a mature hurricane in a single day can exceed the total electricity generated by every power plant on Earth combined. Imagine every coal plant, nuclear reactor, wind turbine, and solar array feeding power into one immense grid. Even that would not match the output of a single powerful hurricane. Most of this energy is released through heat carried by condensing water vapor. The rest appears as powerful winds and towering waves that batter coastlines. Standing near the outer edge of a hurricane, a person might feel only a fraction of this power. From space, however, satellites reveal the full scale of these swirling atmospheric engines. They are among the most impressive natural phenomena on our planet. The calmest place inside a hurricane is its eye. Inside the violent chaos of a hurricane lies something surprising, a place of calm. At the center of the storm is a region called the eye. Here, after hours of intense winds and driving rain, the atmosphere suddenly quiets. Clouds may break apart. The sky can even reveal patches of sunlight. The eye typically spans 20 to 40 miles across. Winds weaken dramatically, and the ocean surface becomes relatively calm. But this peaceful region is surrounded by the eye wall, a ring of towering thunderstorms where the hurricane's strongest winds occur. The eye exists only because the surrounding storm spins with such ferocity. It is like the still center of a spinning wheel. Those who experience the passage of a hurricane eye often describe the moment as eerie and unforgettable. A brief silence before the storm returns from the opposite direction with full force. Monsoons can transform entire landscapes in a single season. In many regions of the world, life follows the rhythm of the monsoon. Monsoons are seasonal winds that change direction during the year, bringing enormous shifts in rainfall. For months, dry land may sit beneath cloudless skies. The soil cracks, rivers shrink, and the air grows heavy with heat. Then suddenly, almost overnight, the sky opens. Dark clouds gather, thunder echoes across the horizon, and rain begins to fall. Rivers swell rapidly, fields flood, dry valleys turn green again. Entire forests seem to awaken as plants burst into growth. Monsoon rains are both generous and dangerous. They provide the water that feeds crops and sustains hundreds of millions of people. But they can also bring floods, landslides, and storms powerful enough to reshape the land. In countries such as India, parts of Southeast Asia, and regions of Africa, cultures have developed around the timing of the monsoon. Farmers plant and harvest according to its arrival. Festivals celebrate the first rains. To witness a monsoon is to watch the atmosphere shift on a continental scale, a vast turning of winds that changes the face of entire nations. The Atacama Desert can go decades without rain. There are dry places on Earth, and then there is the Atacama Desert. Stretching across northern Chile, it is considered the driest non-polar desert on the planet. Some weather stations in the Atacama have never recorded a single drop of rainfall. In certain regions, measurable rain may not fall for decades. The soil here is so barren and lifeless that scientists from NASA have studied it as an analog for the surface of Mars. Yet even in such extreme dryness, life manages to persist. Some plants capture water from coastal fog drifting inland from the Pacific Ocean. Microscopic organisms survive hidden deep beneath the surface. And when rain finally does arrive, which happens only rarely, the desert undergoes a transformation. Seeds lying dormant for years suddenly awaken. Wildflowers bloom across the desert in a spectacular event known as the Desierto Florido, the flowering desert. Fields of purple, yellow, and white blossoms spread across the sand. Standing in the Atacama is like standing in one of the quietest places on Earth. A place where the sky feels endless and every drop of water is precious. The wettest place on Earth receives towering walls of rain. In northeastern India lies a village called Mawsynram. It holds the title of the wettest inhabited place on Earth. Every year, monsoon winds carrying moisture from the Bay of Bengal rise into the hills surrounding the region. As the moist air climbs, it cools and releases its water as rain. The result is extraordinary. On average, nearly 12 meters of rain fall here every year. That is almost 40 feet of water. During the peak of the rainy season, rain falls so heavily that waterfalls appear suddenly along cliffs and hillsides. Streams overflow, roads become rivers. The constant roar of falling water becomes a part of daily life. Homes are built with sturdy roofs designed to withstand the endless downpour. Villagers even grow living bridges from tree roots to cross swollen streams. In Mawsynram, rainfall is not measured casually. It is measured in immense torrents that return year after year. This place reminds us that weather is never evenly distributed across the planet. Some landscapes thirst endlessly. Others live beneath nearly constant rain. The hottest temperature ever recorded could melt car tires. In July of 1913, the desert air in Death Valley, California, reached a temperature almost beyond belief. The official measurement recorded that day was 56.7 degrees Celsius. That is 134 degrees Fahrenheit. It remains the hottest reliably recorded air temperature on Earth. Under such intense heat, asphalt roads can soften. Metal objects burn the skin when touched. Even car tires can begin to degrade or melt when driven across scorching pavement for too long. The human body struggles in such conditions. Sweat evaporates almost instantly, and without water, the risk of heat stroke becomes extreme. Death Valley earned its name from these harsh conditions. The desert landscape shimmers beneath waves of rising heat. Although other regions of the world, including parts of Iran and Kuwait, have recorded similar temperatures, Death Valley still holds the official record. These extreme temperatures remind us that the atmosphere above us is capable of incredible intensity. It is not always gentle. Sometimes the air itself becomes a furnace. The coldest air on Earth can freeze metal. At the opposite extreme lies Antarctica. Far from the ocean, high on the Antarctic plateau, stands a research station called Vostok. In 1983, scientists there recorded a temperature of negative 89.2 degrees Celsius. That is colder than dry ice. Cold enough to make steel brittle and glass extremely fragile. More recent satellite measurements suggest that temperatures in nearby valleys may drop even lower, approaching negative 98 degrees Celsius. In such extreme cold, breath freezes into tiny crystals the moment it leaves the lungs. Machines struggle to operate. Exposed skin can freeze within seconds. These conditions are even colder than the average surface temperature of Mars. Living in such environments requires careful preparation. Scientists rely on insulated buildings, heated equipment, and specialized clothing to survive. Yet even here, in the frozen heart of Antarctica, weather continues its slow movements. Winds howl across the ice. Snow drifts across the landscape. Clouds pass silently overhead. It is one of the most extreme environments on Earth, where the atmosphere meets the deepest cold our planet can produce. Heat waves kill more people than any other extreme weather. Storms and floods often capture headlines because their power is dramatic and visible. But the most deadly form of weather is often far quieter. Heat waves. When temperatures remain high for days or weeks without relief, the human body begins to struggle. Heat stress builds slowly. The heart works harder. Dehydration increases. In cities, the problem becomes even worse. Concrete and asphalt absorb heat during the day and release it slowly at night. This creates what scientists call urban heat islands. Even after sunset, temperatures remain dangerously warm. Across the world, heat waves have taken tens of thousands of lives. The elderly, the very young, and those without access to shelter or cooling are especially vulnerable. Unlike hurricanes or tornadoes, the danger of heat waves is often invisible, but their effects appear in overwhelmed hospitals, damaged crops, and ecosystems under stress. Heat waves are one of the most silent yet powerful threats created by weather. Fog can be so thick you cannot see your own feet. Fog is one of the quietest transformations in weather. It is simply a cloud that has descended to the ground. When fog forms, tiny droplets of water suspend themselves in the air, creating a pale mist that softens the landscape. Distant buildings blur. Trees become ghostly silhouettes. Sounds grow muffled. But in rare conditions, fog can become extraordinarily dense. Visibility may shrink to only a few feet. People walking through such fog sometimes report being unable to see even their own feet clearly. In thick fog, sound behaves strangely. Voices seem closer. Footsteps feel muted. Airplanes must remain grounded. Ships move slowly through harbors. Drivers inch forward carefully along roads. Despite its soft appearance, fog can be extremely dangerous, and yet walking through it can feel strangely dreamlike. The edges of the world dissolve into whiteness. Only your breath and the quiet surrounding air remain. Dew can provide enough water to sustain life in deserts. In the quiet dryness of deserts, rain may fall only a few times each year. But another source of water appears almost every morning: dew. As the sun sets and the ground cools rapidly, the air near the surface may reach a temperature where moisture condenses. Tiny droplets form on stones, leaves, and even grains of sand. By dawn, the desert landscape can be covered in delicate beads of water. For plants and animals adapted to these harsh environments, this dew is essential. Certain desert beetles raise their bodies into the air, allowing droplets to slide down toward their mouths. Some plants channel the moisture along their stems, guiding it toward thirsty roots below the sand. Humans have even designed special nets and surfaces that capture dew from the air. Though each droplet seems small and insignificant, together they provide vital water in places where rainfall may not appear for months. Dew is desert rain delivered in whispers instead of storms. Frost crystals can grow into spiky forests of ice. On cold winter mornings, frost sometimes decorates windows and leaves with delicate patterns. Feather-like shapes spread across surfaces, intricate designs resembling ferns or lace. These patterns form when water vapor freezes directly onto a cold surface. But under certain conditions, frost can grow into something far more dramatic. On mountain ridges and polar plateaus, frost may develop into sharp, towering ice crystals known as hoarfrost. These crystals can stretch upward like tiny frozen needles. Some grow several inches long. When sunlight strikes them, they sparkle like glass sculptures scattered across the landscape. Each crystal grows slowly as water vapor continues to freeze onto its surface layer by layer. Entire fields may become covered with these fragile, icy structures. Yet they are incredibly delicate. A single step or breath of wind can shatter them instantly. For a brief moment, however, frost can transform the world into a frozen forest of shimmering ice. Ice storms can coat entire cities in glass. Ice storms are among the most beautiful and dangerous forms of winter weather. They occur when rain falls through a layer of freezing air near the ground. Instead of turning into snow, the raindrops remain liquid but become supercooled. The moment these droplets touch a surface, they freeze instantly. Roads turn into sheets of invisible ice. Tree branches become heavy with transparent layers of frozen water. Power lines sag under the weight. At night, streetlights reflect from every frozen surface, making the world glitter as though covered in crystal. Every twig and blade of grass becomes encased in glass-like ice. But beneath this beauty lies danger. Roads become nearly impossible to travel. Branches snap under the weight. Entire neighborhoods may lose electricity for days. Walking outside during an ice storm can feel like stepping into a fragile world made of frozen jewels. Everything sparkles, but every surface is slick and treacherous. Dust devils can rise higher than skyscrapers. On hot, dry days, the ground warms unevenly. Pockets of heated air begin to rise from the surface. Sometimes these rising columns of air begin to spin. When they do, they form a swirling vortex known as a dust devil. Many dust devils are small, only a few feet across. They dance across parking lots or empty fields, lifting leaves and sand into spinning columns. But occasionally, dust devils grow enormous. Some have reached heights taller than skyscrapers. Unlike tornadoes, dust devils form beneath clear skies. They may appear suddenly in deserts, fields, or even urban areas. Most are harmless, but larger ones can topple fences, tear loose roofs, or fling debris through the air. Pilots have reported seeing massive dust devils towering across landscapes like temporary giants. They reveal how alive the atmosphere can be, even on days that appear calm and quiet. Waterspouts can spin across the ocean like watery tornadoes. Imagine standing along a shoreline and watching a twisting column rise from the surface of the sea. Mist and spray spiral upward, connecting the ocean to the clouds above. This phenomenon is called a waterspout. Waterspouts resemble tornadoes, but form over water. Some are relatively weak and short-lived. They drift harmlessly across lakes or bays before fading away. Others can become powerful enough to overturn boats and whip the ocean into violent waves. Fishermen have long told stories of seeing these ghostly funnels appear suddenly on the horizon. From a distance, they can look strangely beautiful, spiraling columns of silver mist illuminated by sunlight or lightning. Up close, however, they are chaotic storms of wind and water. Waterspouts remind us that the same forces that create tornadoes on land can also twist the open sea. Microbursts can push airplanes toward the ground. Among the most dangerous hidden threats in thunderstorms are microbursts. A microburst occurs when a storm releases a sudden surge of cold air that plunges rapidly toward the ground. When this air hits the surface, it spreads outward in all directions at high speed. To people on the ground, a microburst may feel like a sudden explosive blast of wind. Trees may snap, fields flatten, debris scatters across the landscape. But for aircraft, microbursts can be especially dangerous. A plane entering a microburst may suddenly encounter strong downward winds. These winds can reduce the lift beneath the aircraft's wings, forcing it downward faster than pilots can respond. Several tragic aviation accidents in the past revealed how dangerous microbursts can be. Today, airports use advanced radar systems designed specifically to detect them. Microbursts usually last only a few minutes, but during that brief moment, winds may exceed 100 miles per hour. They are invisible until they strike. A sudden reminder that storms can release tremendous power in unexpected ways. Supercell storms can grow larger than entire states. Most thunderstorms are short-lived and relatively small. They form, release rain and lightning, and fade within an hour. But some storms grow into something much larger. These are called supercells. Supercells are massive rotating thunderstorms powered by powerful updrafts. They can last for many hours and travel across entire regions. On satellite images, a single supercell can stretch across hundreds of miles. Within their towering cloud structures, which can reach more than 10 miles high, an entire system of weather unfolds. Lightning flashes thousands of times. Hail grows inside powerful updrafts. Tornadoes may form beneath rotating storm clouds. Supercells are rare, but responsible for many of the most destructive weather events on Earth. Watching one form on the horizon can feel like witnessing the atmosphere gather strength. A dark wall of cloud slowly expanding across the sky. Storms that appear almost alive, rotating, growing, and breathing above the land. Some places on Earth experience lightning almost every night. Along the shores of Lake Maracaibo in Venezuela, one of the most extraordinary weather phenomena on Earth occurs. It is known as the Catatumbo lightning. On many nights of the year, thunderstorms form repeatedly over the same region where the Catatumbo River flows into the lake. These storms produce lightning again and again, sometimes for hours without pause. In a single night, thousands of lightning flashes may illuminate the sky. The storms occur so frequently that sailors have used the distant glow as a natural lighthouse for centuries. The exact reasons for this persistent lightning are still being studied. Warm, moist air from the Caribbean Sea rises over the lake. Cooler air descending from the Andes Mountains collides with it. The result is a nearly perfect environment for continuous storm formation. From afar, the horizon flickers endlessly with silent flashes. the sky appears to pulse with light. Few places on Earth display such a constant reminder of the electric energy stored within our atmosphere. Weather balloons travel to the edge of space. To understand the atmosphere, scientists must measure conditions far above the ground. One of the simplest and most effective tools for this purpose is the weather balloon. Every day around the world, hundreds of these balloons are released into the sky. They carry small instruments called radiosondes that record temperature, humidity, air pressure, and wind speed. As the balloon rises higher and higher, the air becomes thinner. Eventually, the balloon reaches altitudes of more than 30 kilometers, far above the cruising altitude of commercial airplanes. At that height, the balloon expands until it finally bursts. The instruments then fall slowly back to Earth beneath a small parachute. These measurements are vital for forecasting storms, tracking climate patterns, and understanding how the atmosphere behaves at different heights. Weather balloons quietly explore the invisible layers above us every day. They drift upward like silent explorers traveling toward the edge of space. Satellites watch the entire planet's weather at once. Before the age of satellites, meteorologists relied only on observations from the ground. Weather stations, ships, and airplanes provided valuable information, but huge areas of the planet remained unseen. Today, satellites orbit high above Earth, constantly observing the atmosphere. From space, they capture images of swirling hurricanes, massive cloud systems, and vast bands of storms stretching across oceans. Some satellites remain fixed above a single region of Earth, watching storms develop minute by minute. Others circle the entire planet, scanning every corner of the atmosphere. Infrared sensors measure the temperature of clouds. Radar instruments detect rainfall. Other sensors track ocean temperatures and atmospheric moisture. Together, these satellites create a global picture of the planet's weather. Thanks to them, meteorologists can watch storms form thousands of miles away. They allow us to see the atmosphere not as scattered pieces of weather, but as one enormous connected system. Weather radar can see inside storms. Another powerful tool for understanding weather is radar. Radar works by sending pulses of energy into the atmosphere. When these pulses strike raindrops, snowflakes, or hailstones, part of the signal bounces back. By measuring these returning signals, meteorologists can map storms in remarkable detail. Radar images reveal the structure of thunderstorms. They show where heavy rain is falling. They can even detect rotating winds that may signal the formation of tornadoes. Modern radar systems update constantly, allowing forecasters to watch storms evolve in real time. A storm that might appear as a dark cloud to the human eye becomes a complex map of movement and energy on a radar screen. With these tools, scientists can issue warnings minutes or hours before severe weather arrives. Radar has transformed our ability to understand and prepare for the atmosphere's most powerful events. Auroras are created by storms from the sun. Far above the clouds and weather systems we experience daily lies another layer of atmospheric activity. High above the poles, beautiful curtains of light sometimes dance across the night sky. These are the auroras, the northern and southern lights. Auroras form when charged particles from the sun stream toward Earth. Our planet's magnetic field guides these particles toward the polar regions. When they collide with gases in the upper atmosphere, energy is released as glowing light. Oxygen produces green and red colors. Nitrogen can create shades of blue and violet. The result is a shifting display of luminous ribbons and waves moving silently across the sky. Although auroras appear peaceful and magical, they are connected to powerful solar storms occurring 93 million miles away on the surface of the Sun. In this way, even space weather can influence the atmosphere of our planet. The Sun and Earth remain forever connected by invisible streams of energy. The atmosphere protects life like a shield. Without the atmosphere, life on Earth would be impossible. This thin blanket of gases surrounding our planet performs many vital roles. It traps heat from the Sun, keeping Earth warm enough for liquid water to exist. It filters harmful ultraviolet radiation. It slows incoming meteoroids, burning many of them into harmless streaks of light before they reach the ground. It circulates heat around the planet through winds and weather systems. Although the atmosphere stretches hundreds of kilometers into space, most of the air we breathe lies within just the lowest few miles above the surface. In that fragile layer, all clouds form, all storms develop, all rain and snow fall. It is a remarkably thin shield protecting every living creature on Earth. Seen from space, the atmosphere appears as a faint blue glow hugging the curve of the planet, a delicate veil safeguarding an entire world. Weather connects every place on Earth. Storms forming over oceans can influence rainfall thousands of miles away. Winds carry dust from the Sahara Desert across the Atlantic Ocean. Moisture evaporating from tropical seas may eventually fall as rain in distant forests. The atmosphere constantly moves heat, water, and energy across the globe. No region exists in complete isolation. Weather in one place can ripple outward and shape conditions far beyond the horizon. In this sense, the sky above us is part of a shared planetary system. Every breeze, every cloud, every storm participates in the vast circulation of Earth's atmosphere. The weather we experience today may have begun its journey days earlier on the far side of the world, and the air we breathe may have traveled across oceans and continents before reaching us. Weather is not only local, it is global, a continuous story unfolding across the entire planet. Clouds may travel thousands of miles before releasing rain. The clouds we see drifting slowly across the sky are often travelers on long atmospheric journeys. Water evaporates from oceans, lakes, rivers, and forests. This invisible vapor rises into the atmosphere, where cooler temperatures cause it to condense into tiny droplets. These droplets gather together to form clouds. But clouds rarely remain in the place where they first formed. High-altitude winds can carry them across continents and oceans. A cloud that begins its life above the warm waters of the Atlantic may travel for days before finally releasing rain over distant land. In this way, the water falling during a quiet afternoon shower may once have been part of a distant sea. The atmosphere acts like a vast conveyor belt, transporting moisture across the entire planet. Every drop of rain has a history, a long, invisible journey through the sky. Some clouds are taller than Mount Everest. Thunderstorms can grow into towering structures that reach astonishing heights. The strongest storms produce clouds known as cumulonimbus. These clouds expand vertically as powerful currents of warm air push upward through the atmosphere. The tops of these storms may reach more than 12 miles into the sky. That is higher than the peak of Mount Everest. At those extreme altitudes, temperatures are so cold that the tops of the clouds spread outward into flat shapes resembling anvils. From a distance, these anvils can stretch across huge sections of the sky. Inside these massive towers, powerful updrafts and downdrafts move air, water, and ice through complex circulations. Lightning flashes, hail forms, heavy rain begins to fall. A cumulonimbus cloud is like a vertical city of weather stacked mile upon mile above the ground. Yet to someone standing far away, it may appear as just another distant cloud drifting quietly across the horizon. Jet streams are rivers of wind high above the earth. Far above the clouds that produce weather, powerful currents of air race across the planet. These currents are known as jet streams. They flow through the upper atmosphere at altitudes where commercial airplanes often fly. Jet streams can move at speeds exceeding 200 miles per hour. Unlike surface winds, they form narrow bands that twist and curve across continents. Meteorologists often describe them as invisible rivers of air. Jet streams play a major role in shaping weather patterns. They guide storms across oceans and land. They separate cold polar air from warmer tropical air. When the jet stream shifts north or south, entire regions may experience sudden changes in temperature and rainfall. Pilots sometimes take advantage of these fast-moving winds to shorten flight times. A plane flying within the jet stream can travel much faster across the sky. Though invisible to the eye, these high-altitude winds quietly steer the atmosphere like giant currents in the ocean of air. Rain can fall while the sun is shining. Sometimes a rain shower appears even while sunlight fills the sky. This phenomenon is often called a sun shower. Sun showers occur when rain falls from a cloud that is drifting through otherwise clear skies. The cloud may be far enough away that sunlight still reaches the ground beneath it. As raindrops fall through the bright air, they can create sparkling reflections that look almost magical. In some cultures, sun showers are surrounded by folklore and curious stories. But scientifically, they are simply the result of shifting clouds and scattered rain. Occasionally, sunlight shining through falling raindrops can even create a rainbow. The mixture of bright sunlight and gentle rain gives sun showers a peaceful, dreamlike quality. It is one of the rare moments when storm and sunshine share the sky at the same time. Rainbows are circles, not arches. When we look at a rainbow from the ground, it appears as a colorful arc stretching across the sky. But the true shape of a rainbow is actually a full circle. The circular form occurs because sunlight bends and reflects inside millions of falling raindrops. Each droplet acts like a tiny prism, separating sunlight into its different colors. From the ground, the horizon blocks the lower half of the circle, leaving only the familiar arc visible. But from high altitudes, such as an airplane or a mountain peak, it is sometimes possible to see the entire circular rainbow. In those rare moments, the rainbow appears as a glowing ring surrounding the viewer's shadow. It is a quiet reminder that the sky often hides shapes and patterns we cannot fully see from where we stand. Wind can travel across oceans carrying entire ecosystems. The wind does more than move clouds. It also transports tiny particles of life across the planet. Dust storms rising from the Sahara Desert, for example, carry enormous plumes of mineral-rich dust across the Atlantic Ocean. Satellite images sometimes reveal these clouds of dust stretching thousands of miles. When the dust eventually settles over the Amazon rainforest, it delivers nutrients that fertilize the soil. Microscopic organisms, spores, and even tiny insects may travel along these atmospheric highways. Some journeys last days or even weeks. In this way, the wind connects distant ecosystems. A grain of dust lifted from African deserts may eventually help nourish plants in South America. The atmosphere is not only a system of weather, it is also a bridge linking life across continents. The sky above us is full of invisible travelers. The sound of wind changes depending on what it touches. Wind itself is silent. What we hear during a windy day is actually the sound of air interacting with the world around us. As wind passes through trees, it rustles leaves. Across open grasslands, it creates a soft whisper. When it moves between buildings or across mountain ridges, it may produce deep, haunting tones. Different surfaces create different sounds. Branches creak, wires hum, sand skitters across the ground. The stronger the wind becomes, the louder these sounds grow. In storms, the combined noise of moving air and shifting objects can feel overwhelming. Yet on gentle evenings, wind moving quietly through leaves can be deeply calming. It reminds us that the atmosphere is always in motion. Even when we cannot see it, storms can circle the entire planet. The atmosphere is constantly in motion, forming vast patterns that stretch across continents and oceans. Some storm systems grow so large that they influence weather across huge portions of the Earth. In the middle latitudes, enormous weather systems called cyclones can expand over thousands of miles. These rotating systems often form along boundaries where warm and cold air masses meet. Once they develop, they slowly travel across the planet, guided by high-altitude winds. A single cyclone can produce clouds, rain, snow, and wind across several countries at once. From space, these systems appear as enormous spirals of cloud drifting slowly across the globe. They are reminders that weather does not exist in small, isolated pockets. It unfolds across the entire atmosphere as one connected process. The sky above every nation is part of the same moving system of air. Some winds blow for months without stopping. In certain parts of the world, winds follow seasonal patterns that last for long periods of time. Trade winds, for example, have guided sailing ships across oceans for centuries. These steady winds blow from east to west along the Earth's tropical regions. They form because the planet rotates and because warm air rises near the equator, while cooler air sinks farther north and south. Once these circulation patterns are established, they can continue for months. Ocean explorers once depended entirely on these winds to cross vast stretches of water. Even today, trade winds influence ocean currents, rainfall patterns, and the formation of tropical storms. They are part of the great atmospheric engine that circulates heat around the globe. What feels like a simple breeze at the surface is often connected to planetary-scale motion. Clouds can glow red, orange, and gold at sunset. When the sun begins to sink toward the horizon, the light reaching Earth must travel through a much thicker layer of atmosphere. Shorter wavelengths of light, such as blue and violet, scatter away in many directions. Longer wavelengths, reds, oranges, and golds, continue traveling through the air. When this warm light reaches clouds in the sky, the clouds reflect and scatter it in brilliant colors. The result can be breathtaking. Entire cloud banks may glow with fiery shades of orange and crimson. Thin wisps of cirrus clouds may turn soft pink. Even ordinary clouds can transform into luminous shapes floating above the fading daylight. Sunsets remind us that the atmosphere itself is part of the canvas of the sky. Every color we see is shaped by the invisible scattering of sunlight through air. Even the calm ending of a day is influenced by the physics of the atmosphere. The sky is never truly still. Even on the quietest, clearest day, the atmosphere is constantly moving. Air circulates between warm and cold regions. Moisture rises and falls. Invisible currents slide past one another in slow rivers of wind. We may not always notice these movements. The sky may appear calm and empty, but above us, the atmosphere is alive with motion. Clouds form and dissolve. Air flows across mountains and valleys. Temperature shifts slowly from place to place. The atmosphere is like a vast ocean made of air. Just as the ocean has currents and tides, the sky has winds and weather patterns. The stillness we sometimes feel is only an illusion. The air above us is always in motion. Every breath connects us to the atmosphere. Each time we inhale, we draw in air that has traveled across the planet. The oxygen in our lungs may have been released by forests thousands of miles away. It may have once passed over oceans, deserts, mountains, and cities. Air mixes constantly within the atmosphere. Over time, winds carry it across continents and seas. The breath you take tonight may contain molecules that were once part of ancient forests or distant storms. In this way, the atmosphere connects every living thing on Earth. It is shared by every animal, plant, and person on the planet. The air surrounding us is part of a vast circulating system that belongs to everyone. Every breath is a small exchange with the sky. Weather has shaped the history of civilizations. Throughout human history, weather has influenced where people live, how they travel, and how societies grow. Rivers fed by seasonal rains have supported agriculture for thousands of years. Reliable winds allowed early sailors to explore distant lands. Periods of drought have forced migrations and reshaped cultures. Even great historical events have been influenced by the atmosphere. Storms have changed the outcomes of battles. Harsh winters have slowed armies. Favorable winds have carried explorers across oceans. Weather has always been an unseen force shaping the course of history. Though we often think of weather as something temporary and fleeting, its influence has quietly guided human civilization for thousands of years. The sky above us has always been part of our story. The atmosphere is one of Earth's greatest wonders. It surrounds us every moment of our lives, yet we rarely stop to think about it. The atmosphere carries the winds that cool our summers. It brings rain that nourishes forests and fields. It creates storms powerful enough to reshape landscapes. It paints sunsets across the evening sky. And it protects life from the harsh environment of space. Though it may appear invisible, the atmosphere is one of the most complex and beautiful systems on our planet. Every cloud, every gust of wind, every falling raindrop is part of its endless movement. The sky above us is not empty. It is full of motion, energy, and quiet wonder. And tonight, as you rest and listen, the atmosphere continues its ancient dance around the world. Clouds drifting slowly across the darkened sky, winds whispering across forests and oceans, storms forming far beyond the horizon, all part of the same living sky that surrounds us. And while the world outside continues to move, you can simply relax, breathe slowly, and let the gentle rhythm of the atmosphere carry your thoughts peacefully into sleep. Good night.